Hi everyone, welcome to this lecture. So in this lecture, we will discuss two more important activation functions, that is ReLU and a leaky ReLU. So let's start this lecture with ReLU function, which is rectified linear unit. So ReLU is the abbreviation of rectified linear unit function. Okay, so here we have a ReLU and the derivative of a ReLU. We can see that this light blue line is our ReLU function and this yellow line is the derivative of the ReLU function. If we see the ReLU function, it is 0 before 0. That is, for any value which is negative, it is 0. That is, if we pass a negative value to the ReLU function, it will give us a 0. On the other hand, if we see it has a constant slope for any value which is greater than 0. That is, if we pass 2 to the ReLU function, it will give us 2. If we pass 4 to the ReLU function, it will give us a value equals to 4. So for positive value, it will preserve the value. But for the negative value, it will give us a 0. So if we see, this is the mathematical representation of a ReLU function. So its equation is maximum of 0 and x. So if x is equals to negative, in that case, x becomes less than 0 and the ReLU function will select 0. On the other hand, if x is a positive number, in that case, the ReLU function select that positive number. So it preserves the positive number, and for negative number, it will give us a value equals to 0. So this is the property of a ReLU function. We can also see that this ReLU function is a piecewise linear function. Overall, it is not a linear function, but it is a piecewise linear function. If we see before x is equals to 0, its slope is 0. It is a straight line, but its slope is equals to 0. And after x is equals to 0, its slope is constant. So it is linear with slope 0 before 0, and it is linear with the constant slope after x is equals to 0. So it is piecewise linear because throughout its slope is not constant. Its slope is changing throughout its progression. It means it is a piecewise linear. Here is a discontinuity at x is equals to 0. So this discontinuity make ReLU function a non-linear function. Now this is a ReLU function. We can see that if a negative value is passed through a ReLU function, it is giving us a 0. But if a positive value is passing through a ReLU function, it is preserving the positive value. So this is the advantage of a ReLU function. The other advantage is if we see the derivative of the ReLU function, it is 1 for all the positive value. It means it is better than the sigmoid function and the hyperbolic tangent function because its derivative is 1 for all the positive values of x. In that case, there is very less chance of a vanishing gradient. Due to this reason, these days, the ReLU function is the most commonly used function in neural networks. So these are the properties of a ReLU function. So we have discussed already that it is a piecewise linear function. It has the discontinuity at x is equals to 0. That is, before x is equals to 0, it has a different slope, and after x is equals to 0, it has a different slope. This makes it a non-linear function. The second important property is it preserves the positive input and transform negative input to 0. It has a linear slope of magnitude 1 after x is equals to 0. So its slope is constant, which is equals to 1 for the positive values of x. Here is another advantage of a ReLU function, that its derivative is 1 in the positive part and 0 in the negative part. Now, this is not an advantage that its gradient or its derivative is 0 in the negative part. Due to this reason, it may enter into a vanishing gradient problem. Now, in order to solve this problem, that it has a gradient equals to 0 in the negative part, we have introduced another activation function, which is a leaky ReLU function. If we see the leaky ReLU function, it has a small negative slope. It is not exactly 0 for any value which is less than 0. So it has a small negative slope after before x is equals to 0. So here is the definition of the ReLU function. So it will select the maximum value between alpha x and x. It means if x is equals to positive, it will select the value of x. And if x is negative, then it will select the value of alpha x, where alpha is 0.01. So what is the advantage of leaky ReLU then? So here is the advantage of the leaky ReLU. If we see, this is the leaky ReLU function. It is x for greater than 0, and it returns alpha x if any value of x is less than 0. So if we see the derivative, it is 1 for any value of x greater equals to 0, but it is non-zero even for the value of x which is less than 0. That is, its value is alpha, which is approximately equals to 0.01. So in this case, we can see that even for the negative value of the x, the gradient is not 0, but it is a small fraction of a value. So this is the advantage of a leaky ReLU, that its gradient is not 0 both in the positive direction and in the negative direction. And the advantage is the gradient is 1 throughout the positive direction, that is when the value of x is positive. So in this lecture, we learn about the two important activation functions, that is a ReLU and a leaky ReLU function. These are commonly used activation functions in the neural network because they do not enter or they do not create a vanishing gradient problem. So I hope you understood this lecture. Thanks for listening, and I will see you in the next lecture.